students, order doesn't matter. Okay, and the symbolization for combinations, instead of a P, I use a C. We still have our number of objects available, and we still have the number of arrangements, R, but R. But our formula is a little different. Okay, so it's n factorial divided by r factorial. And we're going to take our n minus r factorial. And when we put this in our handy dandy calculators, make sure you guys put parentheses around the entire denominator. Otherwise, you're going to start getting wrong answers, okay? Also, um, if I have more than one number in the numerator in a fraction, like n factorial is one number. If I have more than two, please put parentheses around any of the two numbers because that's going to happen in one of your homework problems. Now, just like we had with permutations, sometimes we don't have an R or R equals N. So in this case, we have C with the subscripts N and N. This time it's not N factorial, it is the number one. Okay. For combinations, when N equals R or N equals N, it equals one. Okay. I haven't come across any examples of that yet for combinations. All right, number 12. Natalie has 16 close friends. How many ways can she choose five to be bridesmaids in her weddings? Now, my other classes, I tried, you know, it's hard to figure out what's a permutation and combination. And I tried several different things, and one that seemed to work best was, hey, she's got 16 friends. Does it matter which order she chooses these people in? No. Okay, no. So we're going to use a combination. And our n, the number of objects are 16. She can choose five, doesn't matter which order they're in. That's why it's a combination. And that's going to equal, well, let's go ahead and put it in our formula. So I have n factorial, 16 factorial, divided by parentheses r factorial. My r is 5 times n minus r. So n minus r factorial. And then we have to close that parenthesis. So that's exactly how we're going to put this in the calculator. So grab your handy dandy calculators. And let's see if we can do this. 16 math prob 4 gives me my factorial symbol. I might look up how to assign that to one key so we don't have to keep doing that. Maybe. Divided by parenthesis 5, bless you, factorial, parenthesis 16 minus 5. I need a factorial, so math prob number 4. And then I need to close off that parenthesis and then hit enter. And we get 4368. So it's a little bit more computing than the permutation, but it's not that much harder, right? Okay, there are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? It doesn't matter which order they're in, right? Unless you want a certain order, the way the kids come to your birthday party. So it's a combination. We have 24 objects, and we're going to choose it 8 ways. All right, you ready? Here we go. 24 factorial divided by parenthesis 8 factorial parenthesis. Now you could do the 24 minus 8 in your head, right? If not, you can write it out. Factorial parenthesis. Put this exactly in the calculator the way it's written. 24 math key probability, the number 4 key to get the symbol, divided by parenthesis 8 math prob 4 parenthesis 24 minus 8 close parenthesis. Need a factorial, so math prob 4, and I need another parenthesis. And I get 7, 3, 5, 4, 7, 1. $14. Abby is adopting kittens from the pet store. If there are 18 kittens, how many ways can she choose 2? Does it matter which order she chooses the 2? No. So it's a combination. Let's see, there's 18 kittens, and she's going to choose 2 of them, right? All right. 18 factorial divided by parenthesis r factorial, 2 factorial, times 18 minus 2, 16 factorial, parenthesis. So I have 18 math prob number 4 factorial divided by parenthesis 2 math prob 4 factorial times 16 math prob 4 for the factorial, and then close that up. 153. Bless you. You're welcome. All right, number 15. There are 12 employees at the sub shop. How many ways can the manager choose 4 of them for Sunday? Doesn't matter if the order we choose them in, right? We just got to choose 4. So it's a combination. There's 12 employees, and there's 4 of them that we need. So we have 12 factorial divided by parenthesis r factorial is 4 factorial. 12 minus 4 is 8 factorial. Close parenthesis. 12 factorial divided by parenthesis 4 factorial times 8 factorial. Close parenthesis. I get 495. Okay? Questions, comments, concerns? We're not going to do 16 because your calculator can't handle it. All right, homework. Now, I gave you the permutations yesterday. Normally, I wouldn't tell you if it's a permutation or combination, right? You're going to have to try to figure, well, not try to figure, but it's not, after you do a couple of these, it's really not hard to, that what comes to you as a combination and permutation. How many ways can 4 candy bars be chosen out of 30? Doesn't matter which order we choose these, right? As long as we choose 4, so that's a combination. Order doesn't matter. How many ways can 13 students line up for lunch? Well, that's a permutation because order does matter. You don't want to be the last kid in the lunch line, right? So order matters. Um, Last classes asked me about like when you have this letters in a word, how many ways you can arrange it. I have yet to think of a counter example of it not being a permutation. So chances are it's going to be permutation. How many ways can you choose 2 books from a shelf of 40? Does it matter which order I pull those 2 books? No. How many ways can 12 swimmers finish in first, second, and third? Well, that's definitely order matters. So that's a permutation. How many ways can Mrs. Sullivan choose 2 students from 27 to put calculators away? Order doesn't matter, does it? Just as long as she gets 2 students. You have enough tickets to play 6 different games at the amusement park. There are 14 games. How many ways can you choose 6? Matter which order you choose them? No. So I think you get the hint, right? Also, you're going to have to do pages 3 and 5. These, the first 6 is the counting principle. Okay, the fundamental counting principle. All you're going to do is, if you remember from yesterday, you have m ways and n ways, so you're just going to multiply the two together. There was one tricky one. I don't know if we did it in this class. Um, Number 6. Let's do number 6 together because it's kind of tricky. When Jack bought his new truck, there were 96 different ways his truck can be equipped. Um, he had 4 choices of engines and 2 choices of transmissions. If the only other choice was color, how many colors were available? So he has 96 different ways. So that's our total, right? Let's see, 4 of those were engines. So here's our M, right? And 2 of the choices transmission. So here's our N. So 4 times 2. And how many colors do we have? Well, we don't know. And what do we always place in front? What do we substitute in? Something that we don't know for a value?
X.
X. So we have 8x equals 96, solve for x. Okay. Any other questions? Guys, don't put permutation and combinations on these. It's just simple. Take m times n. Yep.
Number 1, I got an error when I tried to type it
On the other page. So we have 30 candy bars is our total number of objects, right? We have 4 for our choices or arrangements. If you didn't put parentheses in the right spots, it will give you a wrong answer or an error. So let's do this. So I have n factorial divided by parenthesis r factorial times n minus r factorial. Then you're going to have to close it off. Okay. Now, and in calculator, we have 30 math prob 4, 30 factorial divided by parenthesis 4 factorial parenthesis 30 minus 4 parenthesis factorial parenthesis. I got 27,405. I don't know what to tell you. I'm assuming that you made a mistake with one of the parentheses or something. Okay. Any others? You guys should get this done before you go home for no homework over the weekend.